Okay, so we are going to multiply and divide numbers in scientific notation. So what we're going to do is divide and follow our rules of our exponents. Okay, so the first ones we're going to practice putting numbers into standard form from scientific notation. So remember, 10 to the 4th power tells us how many places we're moving our our decimal. So 2, that's 1 place, 2, 3, 4.
Is this just a review?
Yes, 29,500. You are taking 2.95 times 10,000, which means you're moving your decimal 4 places. You have to add 2 zeros. Okay, remember how to do those? Okay, who would like to try number 2? Destiny.
Can I just say the answer?
Yeah.
So, 5, about 5. But yeah, 5, 8, and then 6 zeros afterwards.
Correct. And how would you read that number?
58 million. That's a great question.
58 million. This is the millions place. 58 million. Okay. Remember, this is your ones place. Tens, hundreds, thousands. 10,000, 100,000, million, 10 million. Okay? But we're going to practice reading numbers correctly. Who would like to do number 3? Now we're going the other direction. Andy, what did you get?
0.034.
Awesome. How do we read that number? Tenths, hundredths, thousands. So it's 34 thousandths. Perfect.
Miss Shoemaker, did you get my email?
Okay, so we have 1 and 62 hundredths times 10 to the negative 5. Preston, what did you get?
0.40162.
Oh, do we know how to read this number? It's a hard one. Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millions, 10 millions. 162.
162 10 millions.
Perfect. Okay, now we're going to go the other way. We're going to put them in scientific notation. So it has to be written as a number between 1 and 10 to a power of 10. Okay? So like this one would be 9 and 74 hundredths times 10 to the 5th power. Okay? Noah, you're going to do number 6, and you're going to stay off that. Okay.
That would be 7.2 to the
10 to the
second.
3rd. 10 to the 3rd. Good. Number 7, McKenna. Negative 9th.
Yeah.
Perfect. And then Destiny, number 8.
5. Oh, wait, hold up. No, I'm reading that backwards.
How do you get a 5?
Oh, that's not working. It would be 2.59
Yep, that's what I got.
times 10 to the negative 3rd.
So we read that as 2 and 59 hundredths times 10 to the 3rd. Okay?
Negative 3.
Yeah, negative 3rd power. Now we're going to write each number in the correct scientific notation. Okay? So we already have them with a number and an exponent, but we need to have scientific notation correctly. We don't have 821. That needs to be a number between 1 and 10, right? So I made this number 2 places smaller, which means this one has to become 2 bigger, right? So that would be 10 to what power? To the 5th. Make sense what we're doing? Remember how to do these? So I need to move my decimal how many places in number 10?
1.
3. So it's 4 and 521. Oh, no, there's a 3 there too. Excuse me. 5,213 10 thousandths times 10 to what power? I made this 3 places bigger, which means this one, or excuse me, smaller. This has to become 3 places bigger.
Yeah, negative 8.
No.
Negative 2.
Negative 2. Okay, number 11. 6,700 times 10 to the fourth. I need to make this one place bigger, right?
Yep.
So if that became bigger, this needs to be one smaller. So it's 10 to what power? To the third.
How'd you get the 3?
You had to the fourth, and since I went bigger,
You just subtract one.
this had to become smaller. Okay, who would like to try number 12?
Me.
Okay, Preston, what did you get?
I'm going to move it 3 places, right?
1, 2, 3. I counted 4.
Or 4. So 2.3 times 10 should be,
I got 4 places bigger, so my answer has to be 4 places smaller, so it's going to be the negative,
3, wait, what? Hold on.
5.
negative fifth power. Got to balance it off. If this one gets smaller, that one gets bigger. If this one gets bigger, the power has to get smaller. Okay? That was our review. Now, when moving the decimal place, remember the phrase Lars. Left, add, right, subtract. I just do, if it gets bigger, the other one has to get smaller. If you move decimals left, you're going to add to the exponent. If you move right, you're going to subtract. So that's another way of thinking of it. Now, your new skill is multiplying and dividing numbers in scientific notation. So you're going to multiply or divide the numbers. If multiplying, use the product rule with exponents. If dividing, use the quotient rule. So if we're multiplying, we add the exponents. If we're dividing, we subtract. Okay? So let's go ahead and multiply these. What's 4 times 6? 24 times 10, and I have 3 plus 4, right? Because I have to add those to the 7th. Now they're not in scientific notation. That has to be 2.4. This became smaller, so this needs to become bigger. Or you can think the left to right. I think that's harder. I think bigger and smaller is easier.
10
To the 8th.
So you have to do all that?
Yeah, that's all. And I don't care if you use your calculators to multiply your coefficients, but you're not going to enter all that in your calculator. It'd take way too long. So in number 14, you have 9.8 times 7.5. You can do that in your calculator if you want.
73.5.
Okay, times 10 to what power? What's 4 plus a negative 3?
Negative 1 or negative 7.
1. You add your exponents, right? So, and if you want to show your work,
It's insane.
4 minus 3, which equals 1. Okay. No, it's not. It has to be 7.35, right? This became smaller, so this needs to get bigger. So I have to add 1 to that, right?
10 to the second.
10 to the second power. All right, we ready for the next page?
You have to do all these?
Yep. So, Casey, you're going to do 15. Multiply 9.5 times 1.4. Okay, so you're going to write 13.3. You got to show your work. Times 10. Add those exponents together. You get negative what? What's a negative 2 plus a negative 3? Negative 5. It is not in scientific notation. I would have to write that as 1.33, right? If this got one place smaller, this has to get one place bigger. So it's to the negative what? Thank you, Casey. Okay, Destiny, you're going to do 16.
48.36.
Perfect. It multiplies, you get 48 and 36 hundredths times 10 to what power?
To the
Negative
negative 7.
7. Okay, now put it in scientific notation.
4.83.
6.
Times, oh, yeah, 6. Times 10 to the negative 6.
Awesome. This got one place smaller. This has to get one place bigger. Okay, McKenna, number 17. This is dividing. Make sure you're dividing. What's 3 divided by 4? 0.75 times 10 to what power? Got to subtract, so you get the second. Put it in scientific notation.
It is in
Nope. One place bigger, one place smaller. Good. Andy, number 18. Divide. 5.2 divided by 8.
0.65.
Times 10 to what power? You have a -4 minus a -7 to the third. Put it in scientific notation.
It is 6.5 times 10 to the second.
Awesome. 6.5 times 10 to the second. Okay, Noah, you get 19.
We're gonna do 9 divided by 1.2.
Go ahead and do that.
That is the one.
Okay, so you get 7.5 times 10 to what power?
10 to the -5.
You have a -6 minus -8. Good. And that's already in scientific notation, so you're done. Okay, Preston, number 20.
And that's already in scientific.
So 2.56 times 10 to the 12th.
Huh?
9 minus a -3 becomes plus a positive.
Yeah, but 6.4 divided by 2.5.
Okay, so then 21, you're just going to multiply. Product, right, means to multiply. 7.2 times 5.1 gives you 36.72 times 10. If you subtract these, 8 minus, or excuse me, you're adding them a product. 8 plus a -6 is times 10 to the second, right?
Second.
Scientific notation is 3.672. This became smaller, so this needs to become bigger. Times 10 to the third.
Plus 1 plus 1.
Now you divide. 2.9
Times
divided by 4, which is 0.725, right? Times 10, you have a -2. You have to subtract these because it's division. Minus a -9 gives you what? 7. Put it in scientific notation, so I need to get one place bigger. This needs to be one place smaller. So 7.25 times 10 to the 6th. Word problems. The mass of Earth is 5 97/100 times 10 to the 24th kilograms, while the mass of Jupiter is 1 9/10 times 10 to the 27 kilograms. Approximately how many times greater is Jupiter than Earth? So we have to divide those, right? 1.9 times 10 to the 27th divided by 5.97 times 10 to the 24th. Division will tell us how many times greater something is. So go ahead and divide those. We're approximating. So take 1.9 divided by 5.97.
0.3.
Let's go like 3 decimal places.
0.318.
Through 0.318. Okay. So now if we put that into,
So.
oh, we got it first, times 10 to what power?
The third.
The third. Now let's put that into scientific notation. 3.18, right? Times 10. If this became bigger, this needs to become one place smaller, right? To the
So,
second.
Second.
And then what do we,
Label it as.
that's how many times greater?
Kilograms.
No, it's how many times. So it does not need to, that's how many times. It's 3.18 times 10 to the second times greater.
Times.
It's not kilograms. It's that many times as many kilograms. Okay, Los Angeles uses approximately 4.9 times 10 to the 8 gallons of water per day. About how many gallons of water does the city use in a year? Give your answer in scientific notation. So this is each day, right?
So this is
4.9 times
What are we going to multiply by?
365.
Okay, so you're going to take 4.9 times 365. And you get?
4.9 times 3.
1,788.5.
Times 10 to the
Equals.
8th. We have to put that in scientific notation, so it's 1.7885, right? Times 10 to what power?
10 to the 8.
1, 2, 3 places.
Equals
6.
1.788.
I made my answer 3 places smaller, so I need to make my exponent 3 places bigger. So it's times 10 to what power? The 11th. And then this is going to be gallons, right?
Approximately.
Okay.
How did you know to? Yeah.
Okay, last question. Student loan debt in the United States grows approximately 9.8 times 10 to the third dollars every hour. At this rate, how much debt occurs each week? And give your answer in scientific notation. Okay, so we have 9.8 times 10 to the third every hour,
So divided.
and
by
we're
six.
going to weeks. So first we gotta get to days, right? This is hours. How do I get to days? Or, excuse me.
Divide.
We gotta have, that's how many hours, we have to get to how many days that's gonna be. Times. 1 day is how many hours?
24
So we gotta go
times 24.
times 24.
We can't see it. Oh.
Sorry, it's not reading very good. Times 24. Oh, that's because I had a highlighter. That's why it wasn't working.
24 equals.
So that will give us how many? Hold on. That's gonna give us how many days, right? And how many days are in a week?
7.
Times 7. If we multiply all those, we'll get 2 weeks, right? So 9.8 times 24 times 7.
1646.4.
Times 10 to what power?
3.
The third. Okay, now we need to make it scientific notation.
So 1.6464 times.
So we just made that 3 places smaller, right?
So then 10 to
We gotta make this 3 places bigger.
the 6.
So we gotta add 3 to that. So it's gonna be the 6, and then that's going to be what is gonna be labeled?
Weeks.
No.
Days.
No.
Hours.
Dollars.
Dollars. That's our debt. Holy cow. So in a week, I want to see what that looks like in standard form because I'm a geek, right?
I'll do it. 1, 6, 4.
So that's $1,646,400.